Uh, Today we are going to integrate this expression 1 over 1 plus e raised to power x with respect to x. So we will use substitution and basically the problematic thing here is the denominator 1 plus e raised to power x. So we will call this t. So we are letting t is equal to 1 plus e raised to power x, and obviously if we are letting t is equal to this expression, we have to also find dx in terms of t. So we will differentiate this equation with respect to x. So this will become dt over dx is equal to the derivative of 1. 1 is a constant, so a constant doesn't have any slope. It's a straight line. So its slope will be 0 or its derivative will be 0. So and the derivative of e raised to power x is e raised to power x. So dt over dx will be ex, and we are interested in dx. So uh, uh, by cross multiplication, dt becomes e raised to power x into dx, and we are interested in dx. So from this equation, dx will be dt over ex, because ex was being multiplied with dx. So on the other side it will be divided. So uh, our original expression was 1 over 1 plus ex, and we call this 1 plus e raised to power x as t. So we are going to replace that with t. So this will become integral of 1 over t uh, plus we had dx written alongside 1 over 1 plus ex, and dx is equal to dt over ex. So this will become 1 over t uh, into dt over ex. Uh, and we are basically, we have transformed this integral from x to t. So there should not be anything which has x in it in this integral. So we also need to replace this e raised to power x in terms of t. So t is equal to 1 plus e raised to power x, and we can easily find the value of e raised to power x from here. So e raised to power x is t minus 1 from here. So we'll just replace e raised to power x with t minus 1. So the whole integral will become integral of 1 over t times t minus 1, and we are integrating this with respect to t. So we can see that in the denominator we have two linear factors. uh, Linear meaning the highest power of variable is 1 in them. So t minus 1 is linear because t has power equal to 1, and similarly t is also linear. So whenever we have two linear factors, we can use partial fraction resolution in order to uh, convert that fraction in the form of uh, two fractions. Or we have two factors here in denominator, so now we can write this whole fraction as a sum or a difference of two uh, fractions. So when we have two linear factors, we can write this as 1 over t times t minus 1. They can be written as a over t plus b over t minus 1. So we basically split the linear factors. We wrote t and t minus 1 as the denominators of these two fractions. But in order for us to write this, or write this expression equal to the sum of these two fractions, we need to find a and b. And for that we will use this equation. 1 over t times t minus 1 is equal to a over t plus b over t minus 1. We'll just multiply with t into t minus 1 on both sides. So on left hand side we'll be left with 1, and on right hand side uh, we'll have a times t minus 1, because t will cancel out, plus b times t. So we are interested in the values of a and b, so we'll simplify this equation. So 1 is equal to at, a is multiplying with t and 1, so it will become at minus a plus bt, and when we take common from the two like terms at and bt, uh, we'll be taking t common from those two terms, so we'll be left with 1 is equal to t times a plus b minus a. So as we can see that the constant on left hand side is 1 and the constant on right hand side is minus a, so a will be minus 1 from here. And when we compare the constants of the coefficients of t on both sides, so we don't have any term involving t here, so the coefficient of t term is basically 0, and the coefficient of t on the right hand side is a plus b, so a plus b is equal to 0, and we have already found a, which is minus 1, so replacing a with minus 1, so minus 1 plus b is equal to 0, so b will be 1 from here. So we have found the values of a and b, and now we can just put these values in that equation and we'll get our fractions. So a was minus 1, so 1 over t times t minus 1 is equal to minus 1 over t, plus b was 1, so 1 over t minus 1. So here I have written that 1 over t times t minus 1 is equal to minus 1 over t plus 1 over t minus 1. And because linearity, we can distribute this integral sign on both these terms. So by applying linear property or linearity property, I should say. So integrating this term with respect to t plus integrating this term with respect to t, and we can move this negative sign out of the integral, and we know the integral of 1 over t. Whenever there is a function written in denominator and its derivative written in the numerator, the derivative is just natural log of absolute of that function. So this minus sign will be taken outside, and the integral of 1 over t will be natural log of absolute of t. So minus natural log of absolute of t, plus if we see here, numerator is again the derivative of the denominator, because the derivative of t is 1 and the derivative of negative 1 is minus 0. So we have again the derivative of the expression in denominator written as a numerator. So again the derivative will be natural log of t minus 1. But our question wasn't in terms of t. We replaced 1 plus ex with t. So t will be written as 1 plus ex, and t minus 1, remember, was equal to ex, so natural log of ex, absolute of ex. So our final answer will be natural log of absolute of e to the x minus natural log of absolute of 1 plus e raised to power x plus the constant of integration.